Hey everyone, and welcome to the Boost Your Biology podcast. My name is Lucas, and I'm the founder of Ergogenic Health. Together in this podcast series, we will go underground to explore cutting-edge health and human performance insights that you simply cannot search on Google to help you upgrade your existence. So, without any further ado, let's jump into today's episode. What is up, everyone, and welcome back to the Boost Your Biology podcast. Today, I'm super excited to have a very intelligent guest on the podcast with me. We have Bam. Bam, welcome to the show.
Thank you. Thank you so much for having me on. Thank you for inviting me. It's late, but I'm really ready to talk about this. It's an important show, I think. We're going to discuss things that will hopefully provide something that hasn't been mentioned much before. So I'm really excited. I haven't been on a podcast in quite a while, so I'd say there's a lot of exciting stuff to talk about.
Yeah.
Definitely. And your show is awesome, by the way. Congrats.
Oh, I appreciate that. Well, I'm happy to have you here. And well, what time is it over there? It's like 1:45 a.m. or?
Yeah, it is 1:45 right now, and furthermore, I haven't had a great week of sleep. But yeah, I can muster on through, and I might be a little bit loud at certain points. My flatmates are sleeping at the moment, so I'm going to try and keep it down. Actually,
Yeah, awesome. Well, you're back on the show again because you sent me a message on Facebook the other day about some new discoveries, some things that you've come across recently, and you've always been the type of guy that I consider as someone who's on the cutting edge of neuroscience research and hacking the brain and modifying pathways, very similar to the sort of stuff that I love to talk about on my YouTube channel and podcast here. So maybe do you want to give my audience a chance to learn a bit about you and your background? What do you actually do, and how did you get into the space that you're in?
Yeah, thank you. Great question. So, well, I realized when I was like just before 18 that I'm really interested in the brain, and I realized, hang on, this is something that I haven't really noticed about myself before. And then I started really reading, and I went to university to study cognitive neuroscience in London, and I opened my eyes to Google Scholar, and I didn't just study neuroscience. I studied loads of things, and I realized, oh, this is quite a good method of learning, to go on Google Scholar and just print out papers and read them. So I did that for years. And then I got interested in this particular compound called P21, and I realized it's really difficult to make, but you can remake it to make it better and easier. And I got quite inspired then to sort of remake it, to make it better. And that's when I went from just learning about the theory of the brain, which was something I'd done for like 3 years by that point, to realizing, oh, this is going to help me to understand how to make a good molecule and how to modify molecules to make them better. I did my degree for like 5 years, actually. And when I started manufacturing things, I realized that pharmacokinetics were a really understood kind of area when it comes to the brain. And yeah, before long, I got obsessed with peptides and modifying them. And there's such a huge library of peptides. And then I got inspired again by all the different molecular targets that you can use that aren't being properly accessed, because peptides are seen as problematic and uncooperative, but actually if you give them a good chance and you modify them, then amazing things can happen. So I made this modified version of P21, really, and the results were really good, and I haven't looked back, really. And I've been finding new peptides to modify. I made FGL, which is a hell of a peptide. It's incredibly potent, modified with hyaluronic acid to deliver from the nose to the brain. And that's something that's like a tenet of my philosophy, really, is that the nose is the best way to access the brain. And now I've started a master's in molecular neuroscience at Bristol University, and I've got my own company, which hasn't really done much, in the recent past, really, but I've made several molecules, and I recently, relatively recently, made D21, which is something we'll talk about later on. Yeah, that's a new peptide conjugate, and it's dopamine regenerative and super exciting. So
Amazing.
yeah, and now I'm looking into enhancing intelligence really with this next compound that I'm making, because I think intelligence does have a much better chance at being changed from a molecule than an intelligent perspective would think, honestly, because you think, oh, intelligence is really complicated and difficult. How could a molecule change it? But no, the brain has these really multifunctional molecules that seem to be well placed to change intelligent processes.
Yeah,
Intelligent.
you've got an incredible background and fascinating. I mean, you alluded to P21 as the one of the earlier peptides that you came across. What was the initial use for that peptide, like the original use for that particular peptide?
It was originally intended to be used against Alzheimer's, and it was a bit of a breakthrough because it didn't change the usual things that you expect to change in Alzheimer's, the amyloid burden, but it still improved cognition. So that was quite interesting, and it did it through BDNF activity. And Alzheimer's is quite responsive to BDNF healing, but BDNF doesn't last kind of for very long. It's not something that you can continuously hammer and still get the same results. So yeah, and one person with Alzheimer's did try the modified version of P21, and their symptoms got better after 5 days of usage, which goes to show that it does work for that. But I was very interested in it because it releases BDNF from neurons instead of astrocytes, and I thought that this function could be quite intriguing on how it changes cognition. Not just as a way to help Alzheimer's, but also healthy people having more neuronal BDNF could have better or really interesting cognitive improvements. It's
Well,
definitely been seen.
well, straight away there. I mean, we can already dive deep into like a mechanistic side of things. I mean, that what you just said, that it was had the ability to increase BDNF from neurons instead of astrocytes, or is that like, for example, we know that blueberry intake and these polyphenols that we find, flavonoids, a lot of the time you see in research studies that they increase BDNF. Is it mostly just in astrocytes? Is that why this is unique about P21?
Yeah. Usually the default kind of understanding would be if there's BDNF that's released, it's from astrocytes, because usually their job is to produce these growth factors and distribute them onto neurons. But when neurons do it themselves, the BDNF gets in unique places where it wouldn't do normally, and so you get different synapses and dendrites that have this action. So different information is being affected. So yeah, that's quite intriguing. I don't know specifically about blueberry though, to be fair.
Yeah.
Polyphenols are quite special.
Yeah, like the pterostilbene and like the resveratrols. Like you see, there's so many. If you go on like PubMed and you search like any sort of flavonoid or like any sort of polyphenol, like luteolin or like apigenin, things like that. Like you search apigenin and then you type in like BDNF and there's like at least one article will pop up.
Yeah, right. For like everything increases BDNF basically. Not breathing properly, eating properly, not eating properly. It's all BDNF constantly. Like frustrating. The ventral tegmental area is a place where if you have BDNF there, then you'll get depressed. So, as
Yeah,
you know.
yeah. That's an interesting pathway that is discussed, which is like, yeah, excess BDNF can also contribute to mood disorders. Like, did you want to sort of elaborate on that?
Yeah, well, I could relate to this later on as well, but yeah, synaptic plasticity can be used in good and bad ways. And if you're going through a mood change, then that may require like BDNF to then change your synapses. So if you go from being fine to then being depressed, then you're going to have that's a plasticity mechanism that's required. In the default mode network, I could imagine there being plasticity that's needed to then lock in so that it's difficult to get out of that.
Mm.
Yeah, and there's In fact, yeah, the protein that I'm working on has been implicated in mood levels, and it's a form of metaplasticity. So, like the mood that you carry with you from one day to the next, that's quite sort of long. Not just you had a bad morning, but like you have a bad week. That's the kind of thing that's regulated by really highly potent plasticity mechanisms that change specific dendrites on specific neurons.
That's cool. That is wild.
Yeah.
Wow.
Yeah. So yeah, but a lot of this is kind of like unconfirmed as being proof, but this is what I've seen research scientists say, that yeah, these long-term mood changes relate to metaplasticity.
Yeah, you also mentioned before around the nasal delivery. You said that you learnt over the years that nasal delivery of certain medications or peptides or compounds is a highly effective route of administration. Do you want to explain to my listeners why is that the case?
Yeah, definitely, because lots of people have like mediocre experiences when they take something through the nose and much better experiences in other ways. So, firstly, the nose is really variable, so it can be a bit unreliable. But if you design a molecule with the knowledge that it's going to go through the nose, so with certain compounds that are designed well, that's when you can access the best form of transport. It's not necessarily true that all different compounds will work better through the nose, but there's definitely ways that the nose has to get things to the brain. You have in really healthy people who don't smoke, for example, and have a really good regenerative system in their body generally, then there's this migratory stream of stem cells that go from the olfactory bulb to the hippocampus, basically where the new neurons are generated. That has a lot of cells that are clumped together and processes that can often be hijacked by drug delivery systems to get things straight to the hippocampus. You of course also have the trigeminal nerve, which is really good to get things straight to like the midbrain thalamus kind of area. And of course, you have paracellular transport, which goes through the olfactory bulb and then gets to the frontal cortex really well. You can see many examples of intranasal transport being better than intravenous transport.
Wow.
And although, that's quite surprising. Like, and the frontal cortex penetration is better than intravenous, but it does vary a lot between methods as to how good it gets to the frontal cortex, the different delivery methods that you use, because there are many different carbohydrates and proteins and other things that you can use as methods to get a drug to the brain.
Interesting.
Yeah.
So what about upon this journey of discovering pathways to sort of improve intelligence and modify personality types and things like that? You did come across a particular receptor that you told me about when I visited you in London last, and you kept hammering it, like you made sure for me to never forget this particular receptor. And on my 14-hour trip on the way home, all I could think about was NR2B, NR2B, NR2B. So,
Yeah, that's totally my responsibility there. I totally did that. Yeah. I do that with a lot of people I meet. I'm a bit of an NR2B, like, I don't know, alarm bell, really. I'm pretty obsessed with it, honestly. So, yeah, it's something that I've seen there be really good research about, but for a long time, I didn't really know why it was so good at improving cognition in rats, right? And there's a bit of a story to it, right? So in 1999, they had seen that there was good reason to think that a certain receptor was important for cognition, right? And so they investigated it and they found, God damn, they're really, really right. Everything that they tested was really improved when they increased this receptor in the brain. Now, so NR2B stands for the NMDA receptor 2B subtype. So it's actually not a full receptor, it's just a subunit of the receptor. The receptor is called NMDA, but the subunit are called NR1, NR2A, NR2B, and there's a bunch of others as well. This particular subunit, which when it makes an NMDA receptor, when it forms part of the NMDA receptor, it means that the receptor closes at a slower rate, so it's open for longer. So it transports ions across. So ions are salt, right? Yeah, and it generates electrical current by transporting it across the membrane. And when it's open for a longer period of time, it means that ions are transported for longer. And this means that neurons have an easier time communicating because the window is longer, because that movement of ions acts as a window for neurons to synchronize together. So if two neurons that are firing action potentials together, if they both have ion channels that are open, it means that they be able to form plasticity and have better communication if the action potentials are timed correctly. Then it'll be like boom, you know. So the longer that channels are open, the easier it is for some certain kind of plasticity called spike time dependent plasticity to happen. So they can be like, ha, you have meaningful information, so do I. We clearly do, because both of our ion channels are open at roughly the same time. That's meaningful. And yeah, with this subunit, it means you just increase LTP by a lot. By a fuckload. I bet a huge amount. More than I've ever seen. 7-fold increase can occur with increasing this. Yeah, that is a lot. I'm telling people like that's a lot. There's lots of other examples of like 5 and 6-fold increase, and you can get kind of close to 7 with some weird mutations of AMPA receptors. But you know, that's cool. But that's not really what makes this receptor special, honestly. It has so many different aspects of its uniqueness. But I first got actually really intrigued by it because it's closes at a slower rate. That's really significant to me because I noticed that the frontal cortex is different to the like back areas, basically occipital lobe, in how it deals with the management of its behavior. The behavior is really different in the frontal cortex, and it seems to go on for a longer period of time. And in areas of the brain that deal more with intelligence and spatial reasoning, as well as socializing skills, they have slower timescales. They have information accumulate over a longer period of time, let it build up before it makes a decision. So probabilistic decision making is something where information reverberates or it just bounces around until a decision is finalized and made. And that requires slow processes, you know, and going right down to the neuron, to the ion channels and making them open for longer is really proven to be a really effective way of increasing the likelihood for positive as well as negative plasticity to happen, like increase and decrease in strength.
So this NR2B receptor is basically, you mentioned the NMDA receptors is just a subtype or a subunit of that NMDA receptor, and it's the NR2B portion that you were fascinated by due to its ability to enable these ions such as sodium, things like that, to transport, and it's open for a longer period of time. That influences long-term potentiation and things like that. At the time that you were researching it, were there any substances, known drugs, natural compounds, or things that would actually interact with that receptor?
Yeah, actually, quite a lot. And they are like good compounds at treating diseases, but they negatively regulate NR2B. So actually, when you look at first glance, it looks like this is a bad receptor, you know. It seems to be an important part of depression because ketamine, as well as several other antidepressants, as well as like memantine, which is used against Alzheimer's, they antagonize it, or at least they antagonize NMDA receptors. So, you know, it would be confusing at first, but because it's to do with metaplasticity, it's not quite what it looks like. You know, it's good when you increase it as well as decrease it, and there are reasons why that is. So when you, I mean, I'll talk a little bit about why it seems like such a bad receptor at first. So when you antagonize it, the NR2B receptor, it internalizes and it goes within the neuron, And there's reason to think that when that happens, it actually stimulates a bunch of good mRNA-based protein synthesis, and then plasticity shoots up, right? Because the neuron, I would think, this is my interpretation, the neuron is saying, there's a whole new level of plasticity that we are going to adopt now. We are not going to be as active anymore because we don't have NR2B on the surface. So that means activity is going to drop. We're going to have less calcium, and we're going to take a state which is less inclined to be plastic. But that means that we can act on that and have more plasticity promoting machinery. So the excitability goes up in certain areas of the brain which have this sort of mechanism. And in rodent brains, if you then like silence the frontal cortex, then a bunch of limbic input increases, and then you get like hedonic responses from the subcortical areas. So then that feeds through and then makes the cortical neurons plastic in a different way. So it's very confusing, and it's very meta, and there's many different ways in which this NR2B is dealt with. So, in some areas it'll do this, in other areas it'll do that. But it always acts in a plastic way. It's always a metaplasticity agent. Yeah.
So if the goal is purely looking at it from a enhancing intelligence, are we looking to not antagonize the receptor, right? You're saying instead we want to be, enhancing,
increasing function. Yeah.
Right.
Yeah. From an intelligence standpoint, we'll end up seeing the brain as something that can use NR2B in a really bad way, and we want to avoid that and then make sure that it's increased in function. So it's like turning up the voltage of your brain. It makes it more sensitive, and things can go wrong more easily. If you have an infection, or if you have high oxidation or high inflammation, then that plasticity could go in a bad way. With or addictions as well, loads and loads of things that make you addicted, stupid, or dead, they all increase NR2B functionality in order to do that. But increasing intelligence then is about making use of that NR2B and accessing it in the right way. Your brain knows it, generally it's pretty good at saying, okay, this is going to help neural learning when it uses NR2B in a certain way. Like when it phosphorylates it on certain sites, then it increases its function. When it releases it to the surface in a conditional way on certain dendrites, it says, yeah, this is going to improve your learning ability. And then other times it'll phosphorylate it in other ways, or outside the synapse, and then that's more likely to kill the neuron and bad things happen. But it's a delicate kind of delicate balance, I'd say. But there's definitely lots of potential, and if you do it in the right way, then you could be as healthy as a child, really, because the children have higher NR2B in their brain. Lots of it. So
you're saying, yeah, as a child, obviously, I remember there was a post on the Dr. Ray Pete forum. There was a guy called Hated. He made a post. It was like, babies enter the world in an LSD trip, as in they see the world as if they're just their plasticity is through the roof, sort of thing. So do you reckon there's some sort of, I don't know, correlation there?
Yeah, actually, I read a paper yesterday, and it said that there's lots more NR2B all across the brain, except in the place where you have your working memory, which in an adult they have loads of NR2B just in this working memory circuit, but then less NR2B everywhere else. But in a child brain, it's flipped around. So their somatosensory stuff is going really excited, but they can really barely hold it in their mind's eye. So everything is just coming in and then going out, and it's all so exciting. And I think that's a bit like an psychedelic kind of trip. The small worldedness in these working memory circuits disappears, and you can't hold on to something for very long. But everything else is so exciting.
So what about traditional antidepressants, SSRI? I'm sure you've probably seen research on how antidepressant medications interact with this pathway. Do they appear to have some sort of affinity to the NR2B complex?
Yeah, almost every antidepressant I've seen, all the ones I'm thinking of, they all have a relationship to NR2B, and they basically all decrease it. So when you're thinking, yeah, they decrease it, because if you're depressed, then the thing that makes you intelligent, right, your focus, is also the thing that makes you depressed. So I've literally noted this is a pretty like good pattern I've seen many times, which is, if a bad thing is happening, then the thing that is processing, that is cognitive
Yeah.
skill, is the thing that's the problem, and you need to break that, and then you break the default mode network, for example.
Hmm.
So yeah, if you're a depressed person and then you get super intelligent, my word, you could land up super depressed. But it's complicated, because there's loads of data on positive stimulation of NR2B and NMDA receptors in general, and as long as it's in like basically most of the brain, then it can be really antidepressant. And if it's in your medial frontal cortex, it can be super antidepressant and anxiolytic, and you can see rats just scream with joy constantly. There's data on this antidepressant that I think has been trialed in humans, and the rats are just constantly making ultrasonic squeaks that indicate that they're having a good time, and
Jeez.
it's ridiculous. Yeah,
They
it's
start
pretty
sounding
old.
like,
It looks
I'm just imagining these rats communicating like dolphins. Like,
exactly right. Yeah, I could just imagine one of the dolphins like, "Are you high, bro? That's just squeaking. That's not a normal dolphin squeaking. That's just normal squeaking." Yeah,
jeez.
because yeah, so it changes their behavior a lot, and it interests me how this behavioral change, it may not just be because there's lots more synaptic transmission and a lot of like excitation going on, but it's because it's interacting with specific circuits that relate to mood in particular, and it's actually quite a psychologically related subunit. It's a subunit that does have a psychological specificity. It can deal with specific psychological phenomena because its distribution on different dendrites is so specific. Your neuron is like has a different identity on some dendrites than it does other dendrites. It's really radical that it gets that high of a resolution, you know. Yeah, because then it could control very specific things.
Is there an area of research around NR2B that you think is like lacking significantly, that you think like urgently needs to be researched? Like, is there some sort of, yeah, like element or pathway within this NR2B discussion that you think we need more research on desperately?
Oh yeah, several, definitely several. So the importance of the spontaneous neurotransmission that NR2B makes. It seems to be that NR2B is able to have this spontaneous release of neurotransmitters. And then there's this other brain phenomena called, if I can, low spontaneous, no, random, the amplitude of low frequency fluctuations, which is based on, which it measures like spontaneous neural activity that reflects intrinsic excitability. Now, if you can relate this spontaneous neurotransmission from NR2B and this low frequency spontaneous amplitudes from certain brain areas, because I think they're related, because it relates to intrinsic excitability, which NR2B does as well, then you could make the argument that NR2B relates to creativity and psychological welfare and really deep characteristics of a brain, because there's loads of research behind ALFF is called, and it's a really good predictor of like your general fluid intelligence, how you deal with socializing, and your memory and goal updating in certain ways. And that's really key, because we should understand these processes that are behind creativity, because that's just really fascinating, because that's a different side of intelligence to me.
Hmm.
It can relate to intuition. I really want to understand intuition
Gee.
much better, right?
Is that like
That would
is
be
that like a gut feeling? You mean like it's what is your intuition? Because people say, oh, like just trust your gut, go with your gut feeling. Are there NR2B
yeah.
receptors in the gut?
I think there are actually, yeah. There's NR2B receptors all across the body.
Jeez.
Annoyingly, I know. Yeah, weird, huh? when we talk about D21, I can give some good examples of like how widespread brain proteins are. They're not really in your brain; they're your whole body. It's quite annoying, but
Well, let's
yeah,
let's segue into that. I mean, we sort of spoke about you sort of touched on P21 as the original thing, like the original peptide that stood out to you, but now you've found a way to modify that and synthesize that into something that is this you've titled it D21 yourself.
yeah. This is D21 isn't based on P21 really anymore. It's uses the same modification of drug delivery, which is using hyaluronate. But D21 is all about dopamine, whilst P21 is, about BDNF and more neurons, neuronal regeneration. So yeah, D21 is super exciting. The research on it is going to be really popular in the next 10 years. I'm certain of it. So yeah, I'll mention what it does really and how it works. So there's a fairly recently discovered way that your dopamine system negatively regulates itself in a generic fashion, right? It will stop itself releasing dopamine, it will stop itself responding to dopamine, and it will make you depressed and anxious and stupid and worried and degenerated and inflamed, right? And this way that your dopamine system has of doing this is by taking your one dopamine receptor, your D1, and then another dopamine receptor, your D2 receptor, sticking them together, making a new receptor and influxing calcium into your neurons and reducing the release of dopamine. This new receptor is not your friend, really. It can be cognitively enhancing because it's in bringing in calcium. No, it's releasing calcium from inside the neuron, and calcium is stimulating to neurons, but only for a certain amount of time before it's just annoying, inflammatory, and making a lot of noise, right? And this receptor is actually really good at making noise in multiple ways. It's computationally advanced at making sure that when you get a dopamine signal that you're supposed to have D1 activity to, you get D2 activity. And when you get a dopamine signal that's supposed to elicit D2 activity, you get D1 activity instead. What do you know? You're screwed, really. Everything is reversed. And you can see that the signal to noise ratio is just suddenly really, really bad.
It's
You
like
can barely make out the signal.
it's like there's roadworks going on in the brain, and they're like diverting you. Nah, this road's closed. Now go down this road. Then that road's closed.
Exactly. Yeah, right. And then you go down the road that they told you to go down, and all the traffic is going straight at you, and you're like, "Well, this is really awkward and annoying now. Now we can't even tell if we're going the right way or not." That's what your brain has to deal with. It's a really good way of putting it. Actually, I really like that. Yeah. And who knows? Maybe you do get signals that just go down really inappropriate dendrites or pathways. They just end up being dealt with by inappropriate brain areas for all we know. So because there's so much noise and everything gets messed up. So yeah, and this happens from taking stimulants, from cannabis, from probably being separated from your mother, from stress, repeated, stress, uncontrollable stress. It's a very widespread phenomena that happens, and this receptor gets generated automatically in the areas of your brain that deal with a lot of pleasure. So this pleasure area, the nucleus accumbens, of course, that always makes sure that it has a way of reducing dopamine release because it's doing it all the time and it doesn't want to make you addicted to everything. So it has this collection of D1, D2 receptors to say, okay, well, you liked that cookie, but you're not going to like it for the fourth time at that maximal intensity.
Well, that's like it's dopamine homeostasis. The body will re-regulate and stuff like that. I think uridine. I'm sure uridine has had an effect on that pathway in the past. Like, because on uridine, I want to share my experience with that. Like when I take pretty high doses of uridine back in the day, it would make, it would actually, I find it blunts the rewarding effects of finishing a task. So like once I've crushed
Oh,
an
really?
assignment or finished a task, like I would not get the um, reinforcing effects, or I felt like, okay, I need to keep going to get it, but I never ever get it. So it turns you
Yeah,
into a rat on a treadmill, the hedonic treadmill, isn't it?
yeah, I suppose so, right? But you need a bit of hedonism at least. So, as long as you find doing the task rewarding, but not finishing it, then. But yeah, that's really interesting. I suppose it's doing its job,
Well,
That's really what
it definitely served a purpose. Like it enabled me to like push through barriers and like have great amounts of motivation to complete to like strive towards finishing a task. But the end payoff, but there's also discussion around like the payoff and the rewarding of a feeling is not so much dopamine, it's more the opioid system, right? Like the mu opioid receptors playing a role there.
Yeah, true, true. There might be some serotonin stuff in there as well, actually.
Mm.
Maybe the reward of doing the task is also like interpreted to mean that you're satisfied and that you don't need to do any more tasks. So a healthy, like super functioning dopamine system just doesn't give you any serotonin. I've definitely like felt that honestly. Like if I'm in a really high dopamine state, then I can be really depressed but really functional.
Yeah.
um, yeah, I've definitely noticed that. But although I haven't actually asked the people who've taken D21 these sorts of questions really about how it changes their
So they
like motivation.
the administration. Do you want to sort of talk about D21? The applications so far, the dosages that you've hypothesized. Obviously, for those listening in, this is purely for research purposes only. Like this is not
Of course.
medical advice. This is just purely, for educational purposes. Um, the D21 peptide itself, like the synthesis. Do you want to talk about synthesis, dosages, and route of administration?
Yeah, so it's a 8 amino acid peptide, and there's 4 of these peptides that are stuck onto hyaluronate. That's a polysaccharide that's found in the body already, and it is good at getting from the nose to the brain. Um, and having 4 of these peptides put together hopefully gives it a slightly different quality that maybe I'll talk about later. But yeah, and the dosage varies roughly around 140 up to 250 micrograms, so a quarter of a milligram maximum. And it's liquid and it's delivered intranasally, or it can be theoretically delivered intravenously as well.
To put that,
And
I think to put that into context for the audience, so like Cmax and Selank, those peptides, is that their dosage range is usually 100 micrograms, I think.
I mean, probably a bit higher if it's the just normal Cmax. Yeah, I mean, some people it works really well at like 200 micrograms, but I think most people it's like 500 micrograms for the normal Cmax.
Yeah.
If you have a cetal Cmax, then it's kind of roughly the same dosage almost as the D21. I did hope for the D21 to be much more potent, but we live and we learn. There are lessons there. Yeah, but we had some really good results, and
So what did
the effect
the
lasts a
early
long time.
adopters sort of say about the compound? Like what were their, was it an immediate acute effect? Did they do logs? Did they do cognitive battery tests, things like that?
I don't think we've had any cognitive battery tests actually, but the effects were slightly different to what we anticipated. But yeah, the early adopters were saying that the effects last quite a long time, and it's not like a dopamine. It's really not much of a classical dopamine feeling. Really, it's not exactly stimulating. It's not exactly making you really motivated. It's a very clean feeling of improvement in sensory perception, sense of reward, sense of enjoyment, the desire to socialize, basically desire in general. It makes obviously stimulants quite a bit stronger as well. And sleep improves also. There's sensory improvements, especially the visual stuff. That was the most common thing that I heard was improvement in vision. Everything is HD. One of the best report that we've had, he said that it was like a veil had been lifted from his eyes and he was seeing things again in crystal clear HD like a child, like when he was a kid, which is quite nice. And yeah, socializing improved a lot. One person who just doesn't really talk ever, he said to his barber. Never, ever, ever has he ever struck a conversation with his barber ever. And this time he just did, and he enjoyed it, and it was a good,
Gee,
normal, healthy human conversation.
he did that. He did
Which,
that with. You sure that was him, or it could have been AI communicating to his barber?
maybe, he's got no social skills. It's ChatGPT doing your social skills for you. Oh my God, that's a great idea. I would love that. ChatGPT should just talk for me. I'd
Perfect.
be less autistic. um, yeah, but who needs that now? You have a fixed dopamine system, so you can totally engage. He said, oscillations, feeling like you oscillate with
Hmm.
people, I think he was saying was much better. Hearing got improved in one person as well.
Now, was this
And what's the other
was
thing?
his response like an immediate, or did it take time to build up? He said,
No, it was immediate. It was straight away. With everyone, it either works straight away or it doesn't work at all.
hmm.
It takes like maximum 20 minutes to start working, but it's usually before that people can feel it begin to work.
And is it one of those
Um,
peptides that needs to be like refrigerated to maintain shelf life, things like that?
Not really. I mean, if it's in your house, then you should keep it in the fridge anyway. However, I honestly cannot say how long it takes for it to degrade because all of the compounds that are similar to it haven't degraded yet. What can I say? It takes years to learn how quickly something degrades, and I run out of stock by that point. So
Interesting.
yeah, hyaluronate is a really good conjugate to use to attach to peptides because it increases the half life in every way, basically.
Yeah, interesting. Do you see any like synergies with any other molecules that you've looked into in the past, or you've seen some like stacks that have potentially worked out well at all? Or
From people's reports, I don't think people have stacked it with anything from my knowledge. Apart from like a few stimulants, like coffee was much stronger. It felt like it was not coffee. I don't know what I'm allowed to say on this YouTube channel, but it felt like a strong stimulant. Nicotine was much stronger as well. I think it gave someone a head rush, and they smoke every day, and it gave them a head rush. So something was definitely made more pronounced, I think.
so, if
Um,
from a research perspective, like I mean, if somebody wants to learn about or have a look into the research papers, or like what could we search for in terms of identifying studies on this particular compound?
so if you put D1-D2 heteromer and then dopamine into Google Scholar, then you'll see loads of research on it, and it shows all of these rather sort of depthy, scientific, quite detailed research papers. But obviously, there's a lot more research that needs to happen. I should say that the peptide aims to break this receptor, to break it down so it doesn't work any longer. And instead, what you get is a bunch of D1 receptors and a bunch of D2 receptors. This heteromer, it seems like it's quite able to just move around the brain in a rather non-discriminate kind of way. It just floats around, which means that after years of generating this heteromer, you will have this heteromer everywhere, all across your brain. So then you'll get a bunch of new dopamine receptors all across your brain, which is a rather novel state for your brain to be in. It won't be very familiar with that necessarily. So there's a very big response in some people, huge, and then it kind of settles down a bit, right? As these D1 and D2 receptors are actually taken back and properly assessed as to where they should be, So but the effects do last for quite a while, and it really should, by getting rid of the heteromer, make your dopamine system, which is distributed everywhere, more healthy. So you'll have a better response to dopamine. As for stacks going, it could stack really well with a lot of things. Like uridine, I think it could be a really interesting stack to have alongside that. But basically anything and everything could have a really interesting combination. But obviously dopamine-related things.
Yeah.
Obviously, stimulants are a very problematic thing to combine with it.
Well, this is definitely a compound that definitely interests me. I mean, in the future, hopefully at some stage, I'll get a chance to trial it. I might have to contact you after the podcast to give some a go. Um, if my audience wants to learn more about the actual compound or some of your research studies and things like that, where can they find you and or your research?
So I do a lot of content uploading on YouTube. Actually, that's probably one of the best places to get my output regarding my research. And I have a website called Holistic Research, which I believe by the time this video is released, D21 will be listed on there. So Holistic is with a WH, OLISTIC, and yeah, you might even see the old listings I have as well for the different conjugates. But at the moment, and I also may have a crowdfunding opportunity for the NR2B project to get it funded. Yeah, as a conjugate, which will be really exciting, I'm sure. But that's basically it at the moment. I need to be associated with a really big company, honestly, and that's that's what needs to happen.
Yeah, awesome. Well, I'll make sure to leave those linked in the show notes for those listening in. Um, yeah, that pretty much. Was there any other areas you wanted to chat about in regards to
Well,
these compounds? Yeah.
maybe a little bit on NR2B and just a bit more on the potential of where it could go for further ideas. Because there's one idea which I may have mentioned on the last time we had a podcast, but it's worth saying again, probably,
Yeah.
because I do get asked what the best ways to enhance intelligence could be still. And, it's obviously a really exciting question. I love answering it as well. And it's still pretty much the same. So there's something using magnets, which stimulates two different brain areas, and it stimulates them almost at the same time. And when this happens, because it's nearly at the same time, your neurons see it as meaningful. So they're like, let's strengthen the connections. So your brain strengthens the connections between these two brain areas. And if you have more NR2B, then this has been shown to increase that strength gaining by a lot. And this method of using two magnets to strengthen two brain areas of your choosing has been shown to increase inferential reasoning and deductive reasoning skills. Fascinating, because you may have heard of the P-fit network theory, the parietal frontal integration theory of intelligence. So by targeting areas that are basically here and here, then you seem to change the ability for the brain to engage in tasks we relate to intelligence the most. So intelligence, we say this, but actually we mean a really narrow band of what intelligence can be. It's like doing maths questions, doing logical puzzles, remembering things in a certain order, and using lateral thinking a lot. And that's good and fine, and that sounds very reasonable. But actually, from the brain's perspective, that's just focusing on a few brain areas. If you target the communication power of these brain areas, just the raw ability for action potentials to be made, I think you can release a bottleneck from people's brains. There's a huge range of conditions and in scenarios which reduce the expression of NR2B. They hyper methylate.
Mm-hmm.
Wait, hang on. They hyper methylate, and it reduces NR2B expression, and that can happen from your like car fumes, stress with your friends, from loneliness, from loads of things, and that means that there's not as much power output. Your neurons are not as excitable, and there's not as many forms of cooperative action potential communication, right? Like communication happening. Less plasticity, less responses, fewer responses, and it's more difficult to separate the noise from the signal, and intelligence isn't as high. But if you just give the brain more power, more ion channels, then it seems like you can do a noticeable impact on people's computational power. yeah, it's really exciting, and that's the future I see for NR2B. That's where I think it would be best utilized. But it could also be a really good treatment for things like Down syndrome, schizophrenia, even autism as well. There's this idea that like more glutamate makes more autism. But actually, it's certain kinds of glutamate. If the glutamate that's um, based more in LTD, as it happens, that seems to be the NR2A subunit. That's more autistic. A for autism, and then B, the NR2B is actually
B
related
for
to
bipolar, NR2B bipolar.
yeah. That's funny. Yeah, hopefully not that. Although that would be an interesting topic, really, to think of it that way. Yeah, there's two other subunits called 2C and 2D. So be creative with that. See what you can come up with.
Jeez.
Should be a 2 schizophrenia. But yeah, and we had this report from a prototype, right, that I've made, and the report from this one person. So I know it's n=1, but he said he felt time slow down a little bit. He felt like tunnel vision, really focused, slowed down time. He had a slight sense of arrogance or cockiness, which I find really interesting, because you could justify that perhaps. But yeah, and it sounded like his memory was much better, but it just doesn't last a very long time. We need to improve it and make a more suitable peptide.
Well, you say it doesn't last a very long time, but he said there was time dilation. So whose time are we talking about here?
Very good point, right? Yeah, I suppose we can just make it super powerful. Have you seen the film Judge Dredd? I think it is, where there's a drug that slows down time.
No, but that sounds cool. I've actually I've used when I use high doses of vitamin B1, I feel like time actually accelerates and time goes by faster. I've used a bunch of compounds that make time feel like they're going way faster. And I've always thought that time speeds up when I'm in a flow state. That's how I think. Like, as in, like, time rips by when I'm in a flow state.
Yeah, because I don't think like everything is memorized. You don't remember what you're doing during the flow state. You just wake up, kind of thing, and it's like, wow, an hour has gone by, because your frontal cortex like shuts down. And that's where like memories are really well encoded in the frontal cortex. But yeah, and then you just don't remember what you've done, right? That's a really good sign.
Is the one you're referring to before, Judge Dredd? Is that a dystopian future movie? Like about is that the one?
Yeah. I think it's that one where there's like an inhaler and time slows down massively for like, well, I mean, it's either 8 seconds or it's 80. It depends how you look at it. But there is a compound called deferoxamine. You may have heard of it, and that actually does fucking slow down time reliably across people. I've seen so many reports of people saying, "Yep, slow down time is fuck." And so you have to try that. It's used for another condition, but then if you take a little bit of it intranasally, it takes iron out of your dopamine cells, and it allows them to like have a better pacing, clearly, of time, because there's less of an oxidative load. Because iron is really oxidative. Somehow, yeah, reducing this oxidative burden means that they can function better. What a surprise!
Yeah, I actually do remember you talking about that in London. Now that I remember it,
yeah, good times. But yeah, I really want you to try that, because if you put a video saying this slows down time, that's going to be awesome.
That is definitely a great video topic. I'll have to have to schedule that in the future with some further time ahead.
Yeah, yeah, indeed. I hope you're like not too busy in the next few weeks or so. We'll see.
Awesome.
Yeah,
well, that pretty much, I guess, that pretty much wraps up today's podcast. I mean, Bam, it's always a lot of fun chatting, man. Like, we always jam on a range of different weird topics, I guess, and just so fringe that I don't really see anyone else talking about this sort of stuff online at all. So yeah,
Yeah, thank you, man. Yeah, it's true. I think of myself as like a golden snitch kind of catcher, from Harry Potter.
yeah,
Um, yeah, catching the golden snitch because I don't pay a lot of attention to the other nootropics, but I just have my eyes focused very much on a few small number of things.
mm.
So, but yeah, it's been really fun. You've been a great interviewer. I forgot, how good it is and nice it is to be interviewed by an intelligent interviewer who can, understand everything. So it's been really good. I appreciate it, man.
Yeah, no worries. Well,
Keep doing
I'll
God's work.
I'll make sure to leave everything linked in the show notes for those listening in. Make sure that if you want to get in touch with Bam and some of his research and learn more about what he does, you can find that linked in the show notes. But otherwise, yeah, pleasure having you on, and yeah, we'll be in touch.
Yeah, I look forward to it, man. Definitely. Hopefully, you'll get to try D21.
Yeah,
Huh?
yeah.